The next example I have taken from a 2023 trial paper, and it's from Kelantan, right? So here we have a modulus function and the domain. Okay, so this one is the domain, and the domain is from P to 2. Okay, so the first question is to find the value of P and Q. So P is actually the x coordinate of this point, and this Q is actually the x coordinate of the x-intercept, right? Okay, so to find the value of P here, we can use this 19, because this 19 is actually m of x. As you can see here, the axis is this one. Okay, so what we need to do is use this equation, sub 19 into here. Okay, and since this one is an equation but it has a modulus, so we need to use the technique that we have learned from the previous video, which is to form two versions from this equation and split them. One is the positive version and one is the negative version, and then we separately solve. Okay, so we have two answers here, but there would be only one value of P here. Okay, it cannot be two. Okay, reason is because the x coordinate here, it should be a negative value, correct? So we need to reject one of it, which is this one, because this one is positive, so we need to accept those which are negative. Okay, so our value of P is minus 3. And for Q, since this is an x-intercept, right? So we know that x-intercept, the y coordinate is 0. Okay, so same thing as well, but for the 19, we just substitute 0 here. Okay, using the same technique, you will realize that these two values or these two versions will have the same version, the same thing. 0 equals to 5x minus 4, because even though if I apply positive and negative to 0, it will be the same thing, right? Because it's 0. So this is kind of like a special case. For 0, there will only be one answer. Okay, so by rearranging this equation, we'll get x equals to 4 over 5. And please don't leave your answer as this, because we are finding the value of Q. Okay, so we need to write Q equals to 4 over 5. And the next question, it says, hence state the domain when the range is greater than 4. Okay, so let's recall the keywords a bit. For range is all the values of x, all the values on the x-axis. Range is all the values of y or f of x, which is all the values from y-axis. Okay, so our range here refers to the y-axis, so range is m of x, and it says greater than 4, so we just do write like this. And we need to state the domain is the x value lah. Okay, so what we need to do is solve this inequality, find the value of x. Okay, so now we substitute the function. Okay, and using the technique that we got from here, apply it here. Okay, split into two versions, positive and negative version. Make sure the inequality is changed for the negative version, and we solve accordingly. Okay, so again, there will be two answers, but sometimes answers might not be in this way, because sometimes we might need to consider the domain. Domain is technically our limit, where x must be within -3, which is the P, and 2. Okay, so if our answers is like this, we also need to consider the domain. So if you look at our answers, right, let's say for this one, x is less than 0. So this x, it can be possible that it is -5, because -5 is less than 0, correct? But here, our domain is just until -3. Okay, so what we need to do in our answers, right, is to add another condition, whereby the x must start from -3, which is the starting point of this graph, until our answer, which is less than 0. Okay, same goes to this one as well. For x more than 8 over 5, x can be 3, can be 4, can be 5, but in our graph, it only goes to 2. So this means this 3, 4, 5 cannot be our answer. right? So what we need to do is similar to this one as well. We just add another condition from the domain, which is x must be less than or equal to 2 at the back. Okay, so this would be our final answer. So note that the answer given here is not the same as the one given in the answer scheme. I think they missed out this part, the second part. Alright,